Hello, stats class. Here is lesson 9.2c, which is wrapping up proportion tests. So I wanted to talk a little more about the one-sided test versus the two-sided test. So remember, we talked about this a little bit before, that the alternate hypothesis, if it's one-sided, it's a less than or a greater than. And if it's two-sided, then the alternate hypothesis is a not equals. There's basically three different types of null hypotheses you could write. And I'm going to draw a normal curve for each one to show you what's going on. So let's draw some normal curves. You should be really good at drawing normal curves by now. So what's actually happening here? If it's a less than, then we think that our P0 is too high and we suspect it might be lower than that. So we're expecting our P hat to come out down here somewhere. And that means we're going to be finding this little area that is the probability of getting a P hat this much or lower because it's less than. So for this, the P value is this little area, which is normal CDF. And we would go from negative infinity up to whatever our z-score is, negative 99 and z, because we're talking about this area over here. If it's greater than, we would write that alternate because we think that our p hat is going to come out higher. So we expect p hat to come out over here somewhere, and we'd be finding this little area. And you can kind of tell by looking at these, this is why it's called one-sided. One tail is interesting to us and not the other. And so for that, we would do our p-value is normal CDF. And we would put C first and then a positive 99 because we're going to positive infinity. So there's two different ways to calculate depending on which alternate you have. Now there's always a chance that you might be wrong and like you think it's less than, but then it comes out greater than. If that happens, you don't even need a significance test to see that that is definitely no evidence that it's less than. So if you're going the wrong direction, then you'll just get this really huge p-value that's over 50%. And we're not even going to do those because usually we guess right and it's not a problem. Two-sided, well, what that means is I don't really know which direction my p hat's going to be in. So p hat might be over here, or it might be over here, and I don't know which one's going to happen in advance. I don't know which way it's going to go, but either one would be interesting to me. I'd be interested if it comes out over here, and I'd also be interested in if it comes out over here. Both of these are significant regions, so that means that my p-value needs to be both tails added together. Sometimes it's called a two-tailed test. What that does is it doubles your p-value because you calculate your p-value using one of these things, but it only gives you half, and so then you have to get the other half also. So let's think about that for a minute. If you're doubling your p-value, that means it's more likely to be above the 5%, and you're less likely to reject. This reduces the power of your test. So in general, scientists and statisticians try to do one of these whenever they can because they're more likely to reject. These ones you're more likely to reject with these kind because the p-value is lower. So on these two, you're more likely. This one, you're less likely to reject. But we're going to make our decision not based on, oh, we want to reject the null, but we're going to make our decision based on what we think is true about the problem. So we use this if we don't know which direction it will go. And there will always be hints in the problem about that. The good news is you don't usually have to worry about this doubling the p-value thing because if you're using the calculator shortcut, it does it for you. And I don't think I told you the calculator shortcut yet, so let's do that. It handles the doubling automatically. So I'm going to show you that shortcut. It's in the Stat Tests menu, as you probably could have guessed. Stat Tests. And it is officially called a one proportion z-test. It's number 5 on the list. So that one proportion z-test, if I choose it and I do the same thing that I did with the potato thing on 92B, 0.08, and we had 47 out of 500 potatoes were bad, and we thought that it might be more than P0, that was our alternate. You basically have to tell it what your sample is, what your null hypothesis is, and this tells it what your alternate hypothesis is. And then it calculates, and this should be the same p-value that we got in the last set of notes, which is 0.124. But then if I did a two-sided test instead, if I tell it to do a not equals, then my p-value should be double that 0.124, and it is, it's 0.248. It does it for me. It does the doubling for me, so I don't have to worry about that. Also calculates p-hat and reminds you what n is in case you forgot. But I wanted to let you know that if you're doing it with this method, you would need to remember to double. And if you're doing it with the calculator, you don't need to worry about that because it doubles it for you. And then one more thing I want to talk about, and that is that the two-sided test kind of reminds me of that confidence interval thing we did before, because this middle piece is 95% in the middle, and then we have these pieces put together is 5%. The two-sided test is almost equivalent to a confidence interval. I'll tell you why the almost in just a minute. So remember, I guess I'll keep using the potatoes for just a little bit longer. So I had 47 out of 500 is my p-hat. Another way to decide whether it's 8% or not is I could have done a confidence interval. To estimate the true value of p. And if I did that, then I would have this came out to be 0.09 something, right? It was 0.094. Okay, so I could take my 0.094 and plus or minus 95% would be a z-star of 1.96, and then I could do this. The reason I said almost is this would not be the 0.8 in here. It would be the 0.094 times the complement of 0.094, which is 0.906. And then I divide it by 500. So basically, this is p-hat instead of p0. Oops, I meant to say p0, which is why it's almost the same thing. Not quite. It's slightly different because it's the standard error. So anyway, this thing would give me a confidence interval that would tell me that the true proportion is in there somewhere. Actually, maybe I won't even finish that. I'll just say, well, yeah, I guess I will. So let's actually find that value. I'm going to use the shortcut though. Remember, that's a one proportion z interval, and I would type in my 47. Oh, look, it's already in there for me because I did the test. So if I calculate that, I get 0.064 or 0.068 and 0.1195, which is rounding up to 120. And the true proportion, we're pretty sure, is in there. 95% sure P is in this interval. So that's review from chapter 8, but let's think about how that related to what we did with our example in 9.2b. We got a large p-value and we did not reject. The reason we're not rejecting is that 8% is in the interval. That would mean we do not reject. If it happened to be outside the interval, if P0 is not in the interval, then we would reject. So that's another way to make that decision, but it only is almost equivalent if it's a two-sided test. So it's actually probably not good that I used that with the example from 9.2b, because that was not a two-sided test. The confidence interval is the middle 95%. And if I wanted to do a one-sided, we're not going to learn how to do a one-sided confidence interval. You'd have to recalculate your z-star based on this being 5%. We're not going to do that. But you get almost exactly the same results. Like you would reject with the confidence interval the same times you would reject with the significance test method. So optional extra thing that the do step can be done with a confidence interval only if it's two-sided. Because if it's one-sided, you really need to do a different sort of calculation that we're not learning this year. However, the confidence interval has one advantage to it that I'll tell you. It gives you more information than the p-value. In other words, maybe I don't just want to know, is it 8% or is it not, but maybe I want to know just how bad could it be. This is saying that shipment of potatoes could be as bad as 12% blemishes, or it could be as good as only 6.8% blemishes. It could be anywhere in there, and that gives me an estimate of what the true value is. And sometimes I might be interested in knowing that rather than just making a decision yes or no. So it's the shift from chapter 8 to chapter 9 is a shift from yes or no, or from what is the value to a yes or no decision. And how do you make that decision? You could look at a p-value like we've been doing, or you could look at a confidence interval and see if something's in the interval. It's another way to make the decision. So this is just another way to decide if you're rejecting or not. All right, that is enough because we spent some time doing the chart also. And there's a quiz tomorrow, which is Wednesday.